Good morning to the staffs and coordinators who are watching my recording. I'm Ahmed B. from Particular Engineering College, EC Department, E section. My project is done using a simulation software and the concept is a parking sensor circuit. This simple circuit can be used as an aid for sensing the distance between the rear bumper of the car and any obstacle behind the car. The distance can be understood by the glowing of the LEDs. Now let me open my project. So this is my project and this is my receiver side. This is my transmitter side. Okay. At 25 centimeter distance, the D7 LED starts glowing. At 20 centimeter distance, the D7 and D6 LEDs start glowing. And at 5 centimeter distance, all the 3 LEDs starts glowing. If the obstacle is beyond 25 centimeter, none of the LEDs glow. Okay, the components used here are A-stable multivibrator using NE555 IC, comparators LM324, diodes 1N4148, which is called the switching diode, LEDs, 12 volt battery. Okay, capacitors, we are using the polarized ones here, resistors, and also a photodiode. Okay, now let me go to my working. Two ICs are used in the circuit. The IC1 NE555 is wired as an A-stable multivibrator for driving the IR diode D1 to emit IR pulses. The operating frequency of the transmitter is set to be 120 Hz. The IR pulses transmitted by D1 will be reflected by any obstacle and received by the D2 IR photodiode. Okay, the received signal will be amplified by the IC. I'm naming this as IC2A. Okay, the peak of the amplified signal will be detected by the diode D4 and the capacitor C4. R5 and R6. Okay, yeah, R5 and R6 are used for compensation of the forward voltage drop of the diode D4. Okay, this is my D4, and R5, R6 are used for the compensation of the forward voltage drop by the diode D4. The output voltage and the peak detector will be proportional to the distance between the car's bumper and the obstacle. The output of the peak detector is given to the inputs of other three comparators IC2B, C and D. B, C and D. Okay. The comparators switch the status LEDs according to the input voltages, their inverting inputs, and the reference voltages and their non-inverting inputs. Resistances R7, R8, R9 and R10 are used to set the reference voltages for the comparators. Okay, now how would this help to the society? Now a driver finds it difficult to park his car when he is in reverse gear and seeks help from someone to park his car. Now, in order to help him, we have three warnings here. At 25 centimeter distance, the first LED starts glowing. At 20, the second, and at 5 centimeter, all the three. So this will help him by not damaging his car and also the next person's car. Also from damaging his car from any obstacle there. Okay, let me show you the output graph here. Now my circuit is running. Okay, now you can see the output here. The car is getting reversed. You can see the obstacle. This is the obstacle which is getting detected. Even here it's getting detected. You can see another obstacle getting detected. So according to the distance, we get the output waveform. Okay, now let me tell you some important things here. The D1 and D2 must be mounted close 2 centimeter to each other, looking in the same direction. This is my D1 and D2. Okay. The D1 can be a general purpose IR LED. The D2 can be a general purpose IR photodiode with a sun filter. The transmitter as well as the receiver can be powered from the car battery. For proper working of the circuit, some trial and error is needed with the position of D1 and D2 on the dashboard. All capacitors must be rated to 25 volt. The ICs must be mounted on the holders. I hope you loved my circuit. Thanks to the staffs and the coordinators for giving me an opportunity to present my screen.